Today I'll be going through a tutorial of how to use the PWM, which stands for Pulse Width Modulator, also known as a buzzer, on the OBD kill. So you'll see that we have two import statements, one of which is new, which is import PWM. That's what we'll be using as the class to control that pulse width modulator. And as always, it's connected to a pin, which means that we'll use the pin class to create that pin. So we'll begin. We'll create we'll call it buzzer, and that'll equal a new PWM. And referencing the user guide, we'll see that the PWM is connected to pin 20. So now our buzzer has two different attributes that we'll be using. The first is the frequency, which determines what the buzzer sounds like when it buzzes, and then the second attribute we'll be using is the duty cycle, which kind of is just how many times per second that it buzzes. So a larger duty cycle will mean that the buzzer will be louder, and then a duty cycle of 0 means that the buzzer will be off. So the first thing we'll define is going to be our buzzer.frequency, and we'll set this to 200. And then we'll also define buzzer.the duty cycle for this, and we'll set it to 1000. So now that we have this, we'll run. We're already connected to our Pico, so we'll just run the file. I forgot to put the U in there, so let's run that again. And we'll hear that the PWM is now buzzing. Since we don't want to keep listening to that, I will set the duty cycle to 0 and then run it again to stop it. And now I'm going to reference the user guide again, but this time I'm going to reference this map of tones that are already predefined that you can copy and paste right into your code. So I'm going to paste this in here. And what this is, it's a map, which means that you can put the pitch in and then it'll automatically return the frequency that you want to use. So now we'll go through and we're going to create just a very basic kind of cycle. What we're going to do is that we're going to start at nothing, and then we'll slowly increase the buzzing all the way up to 1000, and then we'll let it buzz for a couple seconds, and then we'll decrease the buzzing all the way back down to 0. So to do this, we're going to use a for loop in Python. So it's going to be for I in range, and then we'll start it at 0. And then we'll start at 0, and then we'll go all the way up to 1000. Range. And then we're going to do buzzer, and then we're going to be increasing the volume, which means we'll increase the duty cycle, and then we'll set that to I, and then we're going to use the utime sleep that we talked about in our LED, and we'll do utime.sleep, and then we'll sleep 3 milliseconds. So 3 times 1000, that'll give us a 3-second increase all the way up to 1000. And then we're going to sleep again, this time outside of the for loop, and we'll sleep. And then we'll sleep for 3000 milliseconds this time for another 3 seconds. And then we'll do a final for loop. And then this time we'll take advantage of Python's reversed function, and we're going to reverse the range from 0 to 1000. That way it'll start at 1000 and work its way all the way back down to 0. So then this time we'll do our buzzer, and then we'll set the duty cycle again to I, but since it's going backwards, the sound will be decreasing, and then finally we'll add that delay in there to stretch it over 3 seconds. And then finally, we're going to use this map that we imported to create a pitch for this cycle. So we'll do buzzer dot frequency, and then we'll set it to tones, and then this is just syntax for a map, and then we're going to use the tone C5, and then we can get rid of this because we're not using this anymore. So now we'll go through, we'll set the frequency to C5, and then over the course of 3 seconds, we'll increase the volume, and then we'll hold that volume for 3 seconds, and then we'll decrease the volume. So I'm going to go through and run this now. And that's a brief tutorial of how to use the pulse width modulator on your OBD kill.